Hello world! In this video, we're going to build a bioinformatics project from scratch in Snowflake. And so let's dive in. So the data that we're going to be using is based out of this research paper from John S. Delaney for the paper called ESO, which is standing for the acronym of Estimating Aqueous Solubility Directly from Molecular Structure. So the data set I have already aggregated for you. So they're available here, and I'll provide you the link in the video description. So it's essentially comprised of 5 columns of data. We have the molecular log P, we have the molecular weight, we have the number of rotatable bonds, we have the aromatic proportion, and also the log S column. So all of these are characteristic of a molecular structure. What are molecular structure? They're like drug molecules. And so what we want to do in this project is, given the 4 columns here, which are attributes or description of the molecule, we want to predict its relative solubility. So that is characterized by the column called log S, which is the solubility of the molecule. So let us import the data into a Snowflake platform. So what you want to do is you want to sign up for a Snowflake account. You can go ahead and go to signup.snowflake.com, or also use the link in the video description. And once you're logged in, it will look something like this. So the first thing is we want to import our data. So click on data here. And then all of these here are the existing databases that I have in my account, and they are shared in the organization or the team that I'm on. And so if you want to import your data in here, there are several options available in Add Data. So go ahead and click on it, and then you have several options here. You could load data directly from your files on your own local computer. You could also do this via Snowflake Stage, import from the marketplace, and there's several other ways for you to do that, such as S3 or Google Cloud Storage or Azure. So I'll go ahead and use this option, but then before that, I need to download the data. And so the data that we're going to be using is available here on this page. So I'll go ahead and click on the download raw file. All right, and then the data is already downloaded into my computer. Go back to Snowflake here, click on load data into a table, and then I'll drag and drop. Drag the data, drop it in here, select or create a database. So I'm not going to select an existing one. I'm going to create a new one. Well, actually, I have to select a database to put this table into. So let me go ahead and click on Chanin and demo data. And you could do the same for other locations that you have already created. So make note that you should have already created a database called something, and then you select it in here. And for the schema, I'll just use the default, which is public. There you go. Or actually, if I don't have an existing database that I want to put it to, I could also create one directly here. So I already have Chanin and demo data, which I'm going to put it in there. But if for those of you who are starting out, you could click here on the plus database, and then you could enter your own name. You could use your first name, last name, whatever, and then, click on create. Since I have already done so, I just use the one that I already have. I'll create the new table in here, create new table, because the existing table that I have are comprising of these 2. So I'm going to call it solubility, and then I'll click on next. And the data is being loaded, and these are the columns, which we have already seen on GitHub. And so I'll go ahead and click on load. Awesome. So it's going to be available here. Copy the data here. Or you could click on query data and then is going to open up a worksheet for you. All right, and it gives you some, pre-filled SQL query. And you could click on the run button here, and it gives you the first 10 rows of the database. All right, so it's available here. So next stage is I'm going to open up a notebook. I'll create a new one. Click here, create a new one. I'll choose the database, which is Chanin in demo data. And then I'll click on apps. Run in warehouse. I'll click on create. Okay, and so let me change to a dark theme. There you go. However, if you like light theme, you could continue to use it. So here we have pre-existing cells. So why don't we go ahead and click on start to run the notebook. So if you want to rename your notebook, you have to end the session first. So I have already started the session. So if we want to rename it, we'll have to do it before activating the session. So we could do that later. And so what we're going to do is we're going to see here that there are several cells here. This is a Python cell. So everything in here is our Python code. You could also, make selection for other type of languages like SQL or Markdown. So why don't I click on Markdown and then I'll type in something. I'll type in Solvability project. This is a bioinformatics project from scratch. And then we'll hit on check mark or done editing, or on the keyboard, I'll hit on Shift Enter or Command Enter. And do you see this little dotted lines here to the top left of the cell? Well, it allows to move the cell up or down. Very convenient. And then you could also name the cells here. Okay, let me call this the MD title, because you could make reference to the contents within the cell. So they are kind of like defining variables, which will come in handy in just a few moments. You're going to see that. So yeah, why don't I let you see what the default are looking like. So this first cell will allow you to import Streamlit and Pandas. And then we're going to initiate a session from Snowpark. And then here we're going to, perform some SQL queries. And then you're going to see the query table shown here. And then this is an example of you creating a Streamlit app right inside the notebook. So this is a new experience because typically, normally you would create a Streamlit app as an app. But here you get to use the Streamlit widgets in a notebook, which is pretty handy. And I believe it's very fun. So yeah, this is like a Streamlit app, but then in a notebook environment. So yeah, let me delete these cells and then we're going to continue with our project. So I don't need this as well. So I'll just delete it. And let's see, we're starting from scratch. So we're going to go ahead and create a SQL cell. We're going to call it SQL, which is like the typical convention that I like to use is that if it's a SQL cell, I'm going to start with SQL and then underscore and then the name of the cell that I want to give it. I'm going to give it a name of data because we're going to load the data in. And as you can see, the markdown, I already given it a name of MD title. And well, it's the title of the project that we have here. And yeah, definitely you could use syntax like here to create italic or like this to create a bold font. There you go. That's actually bold. So let's see. That's our data. So we're going to select everything from the data. Let's run it. There you go. We have the data loaded into this cell called SQL data. And we're going to create a Python cell. Let's call it PyData. And then what we're going to do here is I'll call SQL data because as I already mentioned, SQL data is now a variable. So let's say if we call SQL data in a Python cell, let's see what happens. We're going to get a table. But then this table is not yet a pandas data frame. So we have to convert it into a pandas data frame. So what we're going to do here is we're going to say to pandas, and then we're going to run it. And then now is a pandas data frame. And it's assigned to the PyData variable. So in a new cell, I could call PyData, and it's the data in a pandas format. So why don't I rename this to be DF so that it's like in the typical convention that I also use in other tutorials. And now we could just refer to it as DF. Oh, okay. We have to run it first. Let's run it. And then we call it again. There you go. So now we have the DF variable in Python, which corresponds to the data that we had already loaded in for the Delani dataset. And so what we want to do now is let's do some data processing. So we're going to say DF, and then we're going to create labels based on the molecular weight. So we're going to say mo weight class, PD series, and then we're going to do small if X is less than 300, else it's going to be large. So this is a fairly simplistic way of categorizing it. And then we're going to have molecular weight here. And then we could, we could do that. Would that work? Oh, okay. It's all capital. All right. So yeah, let's do that. So it's all capital. Let's just say class like that. Okay. So we have a new column called mo weight class, and we have small, and then we have large. Okay. And then we're gonna do some additional group by, and we're going to group it by the molecular weight class, and then we're going to compute the mean value. But instead of saving it into DF, let us do DF class. So we create a new derivative data frame, and then we're going to return the underlying table that we have created. There you go. So now we have a aggregate of the large molecular weight molecules and the small molecular weight molecules, and then we have the corresponding mean value. There you go. And now what about we create a data visualization? So let's see. Yeah, so I'll add some markdown in order to give it some, some inline text documentation. All right, so that we know what we're doing. So we have MD, and we're given a name shortly after. So here we had imported our data, or actually we loaded our data. So why don't we call this MD data to correspond to SQL data? And then we're gonna give it a 2 hash, which is corresponding to heading 2 or H2 heading. We're gonna call load data. And then like a short description. Here we're loading the Delani data set. And we could actually, link to the original paper. Reference is this one. So I'll delete that hash and then I'll copy it and then I'll put it in here in Markdown syntax. Here we're loading the Delani data set. Okay. And then if you click on reference, you have access to the paper, right? Click on it and then it loads in a new page. All right. Now we have our first section, and then our second section, we're going to, with the H2 heading. So now we're going to convert a SQL output to pandas data frame. We're using the toPandas method to convert our SQL output table to a pandas data frame. There you go. And so we're going to call it the MD toPandas. And yeah, we'll leave it as DF, which is our convention for, creating a new data frame. And now we're going to do, so here we're just, looking at the data frame, which we don't need to have it here. We just delete it and delete that as well. So what we're doing here is we're creating classes out of the molecular weight. So we're doing what MD class, and then we call this PY class. And then we're saying that we're aggregating the data, right? We're data aggregation. Here we're aggregating the data, we're grouping it by, or same meaning, grouping it by its molecular weight, and small if less than 300, large if greater than or equal to 300, because of the else condition that we use here. There you go. We have a nice looking markdown syntax here. And let's see, what else are we going to do? All right, let's see. Okay, let's have a look at the Streamlit docs for bar chart. So we have, various bar charts that we could potentially use. So these are great examples. All right, so it's ST bar chart. Let's do that. Let's go back to our notebook. We're going to import Streamlit as ST. And then we're going to put in our DF class. Let's see, what do we have? Okay, so it's actually using all of the data that we have. So why don't I only give it the okay, so now it's like a stack data. So if I do only the mole weights, mole weights, okay. All right, so if we only give it a molecular weight, this is what we get. Stack false, okay. So there is a stack equals to false. Let's see, what does it look like? I guess we need to specify the X, Y, and the color. X, Y. Okay, let's do X, Y. Let's see. Would this work? X would be the mole weight class. And then Y would be the, let's try mole weight. That work? Okay, maybe it's a new. Oh, maybe we need color. Let's do that. Okay, maybe it needed a newer version of Streamlit. Let's see. This is an older version. Could we do? Okay, so yeah, we're actually using an older version of Streamlit. Oh, it does. Okay, so that seems to be an index. So what if we do this? Would it work now? All right, it works now. So before that, the mole weight class was kind of like an index. So you see that it resides here in the leftmost part, and then we use the reset index function so that it becomes an actual column. And now it seems to work. What about the stack? Well, I don't think we actually need. Let's see it anyways. Okay, so it doesn't recognize it, probably because it's available at a later version of Streamlit. So yeah, this actually does it. I mean, it looks good. And then we could, give it a subheader name. We could say something like molecular weight. There you go. That's the heading. And we could give it some layout. We could do like here, for column, SC columns, and then we're going to do like 2 columns. We could say and then the first column, and then our second column will be here. So we're going to copy our code here. And let's see, aside from molecular weight, we're going to use, well, anything else, everything else, right? Molog P. Let's do molog P. Molog P. Oh, okay. Let me do that for here. Molog P. Molog P. Okay. How about that? Looks good. Okay. And we're gonna do it for the rest. So what else we have? We have number of rotatable bonds, non-rotatable bonds. Number of rotatable bonds. I think it's rotatable bonds. Our y-axis right there, non-rotatable bonds. So yeah, why don't I just, take the parenthesis out. There you go. So yeah, you'll see that the great thing is that whenever we're coding our implementation here directly in a notebook, we could, hit on the shift enter so that it renders the app or data visualization that we're creating, and we're able to, see it in real time if we're doing it correctly or not. So I'll just say bar. How about pi bar, or how about pi app? Because we're essentially creating an app, right? We could give it a name like a normal app, SC title, and then we could add a molecule. I don't think it has a molecule. How about just give it a leaf? Lucky clover. Okay, so we're having this let's call it a solubility dashboard. Yeah, it's interactive, so you could zoom in, zoom out. So here we call it solubility dashboard. And then so before that, how about let me see if I could add some values in a metric. Let's try, let's call it molecular weight, or just mole weight for short. Okay, it's missing. Okay, let me find what to show. DF class, DF class, and then we're gonna get mole weight, right? Mole weight large. Oops. Would this work? Okay. Just the value there. Could we do round? Okay, we could do round. Okay, let's use this. Why don't we call this mole weight? Yeah, let's just call it mole weight. Create a variable, call it mole weight. Oops. We'll put it here then. And then we'll put the mole weight in there. See, does it work? All right, there you go. So we have the mole weight here. So that's for the large. So maybe worth calling it large, mole weight large. And then we should have another one, mole weight small. And then we change that to 1. And then this would be large. And call it large. Yep. Because the mean value for large is here. Okay. Let me check the documentations on columns. We're able to specify the gap here. We're able to specify the vertical alignment. So let's see. We could add borders to it, like border equals to true. Let me try that. Border equals to true. Okay, probably it's not recognized here. It's probably for a newer version of Streamlit. No worries. We'll add it below. Let's see, small, and then this to be small. How is that? Okay, so we have large, small. All right, cool. Let's add it for the other one as well. You know, we're gonna do some manual non-rotatable bonds. We're gonna put it here. So that's the non-rotatable bonds. There we go. And then we're going to call it. We'll put it underneath here. Large, small. Okay, right there. And for molecular block P, mole block P, mole log P. Let's have a look. There you go. Mole. I mean, for this one, we now will have to display it. Mole log P, mole log P. Not defined. Oh, okay. I defined it twice. I'll delete it here. All right. There we go. So we have for the large molecular weight and we have it for the small. Okay, very cool. And let's use another one. Aromatic proportion, and then we also have the log S. So let's do just another one. I think you get to see you get the gist of this. And let's see, aromatic proportion. Aromatic proportion. Proportion. Then we're going to create from this one. Aromatic proportion. Okay, we need to change the name. Right here. Aromatic proportion. Okay, cool. There we go. So we have this cool looking, but it might look a bit redundant. I just created this to let you see how it looks like in a, Streamlit app dashboard style. And what about we let the user, see the underlying table as well, the original and also the processed version. So why don't we add at the bottom here, we could say with STExpander, and then we're saying show original data frame, and then we have the data frame df in here, and then we say with STExpander show what do we call it, aggregated data frame, and then we say the frame and then the df class. Okay, there you go. So you could expand the data frame and take a look at it. Clicking on the columns would allow you to sort the various columns. And yeah, the beauty of this is that you could extend this to perform so much more. You could add some interactivity to it as well. So let's see, what should I add here? How about I add the cutoff for a molecule being classified as small and large? Would that be cool? So instead of saying 300 above here, okay, so in order to do that, we'll have to put this as part of the code. So yeah, we're going to have to take this and then we'll have to, put it in here. So we're calling this data filtering, and then this will allow us to do, calculate metrics. And then the bottom part are the dashboard elements, right? The data visualizations and metrics, data metrics and visualizations. So here we have the number 300. So let me find a slider. Let's see, from the doc, ST slider. So we have the string followed by 3 values, the minimum, maximum, and the selected value. Okay, let me do that. st.slider, st.slider, and then you could say select a value. And then we're going to have a value of, let's say, 100 until 500. And the starting value is 300. And then we're going to give it a variable. What should we call it? Mole size. Mole size. And then we're going to take this variable and we're going to replace 300 mole size. See if it works. We have here. So if I change this value, theoretically, everything below here should change. And it seems to change. If it's 500 here, then the largest molecule here is 581, smallest 201. If I change the value to the lower end here, all right, so yeah, it works. So The slider widget here will influence the data filtering and all of the corresponding data that you see below here. Pretty neat, right? And then, you could add additional widgets to it. See if this works. ST divider. And we're essentially adding a divider line, right? So the slider influences the underlying data filtering. So, and then here, you're able to, switch between the languages in the cell. We could change it into a markdown, and we could say reference, and then, we could provide links. We could copy the title here, and then put it in here, copy a link, put it in here, or even here. st.slider, and then we put in the link, and there you go, right? This is like the reference section, and then you could click on to have a look in more detail. Let me try st expander. st.expander. And we have st expander in here. What else did we use? Bar charts. st bar chart. And we have our reference section pretty much complete. And all of the markdown has already been properly annotated. So I'll delete this. This was like a temporary cell. And yeah, I mean, the beauty of this is that you could create temporary cells for your app. I mean, for your notebook, while you're experimenting with, which variables to create, like I had. So here we're, building the dashboard app, or we could just say dashboard, and then we could say solubility dashboard. There you go. And it was pretty much impromptu. All of this was pretty much built together in this tutorial. So I did not pre-build this like other tutorials. We're building this together from scratch, from, downloading the data directly from GitHub, saving it into your computer, importing into Snowflake, and then retrieving the data into the notebook here. And then we're just, figuring it out as we go along. And you'll be able to see that in just a few moments in time, we had created this pretty good looking dashboard using the Streamlit widgets directly in a Snowflake notebook. And the great thing is that when you're finished here, you could, copy the code here, and then you could essentially go and create your own Streamlit in Snowflake app using the same code here. And so with minor tweaking and modification, you'll be able to have your app, in no time, maybe another minute or so. And so if you have reached to this point in the video, give me the leaf, or actually the clover emoji in the comment section, and let me know what other videos that you'd like me to create. And so until next time, happy coding.